Hello. Hi. I don't know if you could tell or not by the picture, but my presentation is on light microscopy, and I am Jamequia Faison. In this PowerPoint, I will be doing a brief overview of the history, the technique of microscopy, its applications, advancements that have been made over the years, a 4-point review, and then I will open the floor for questions. Certain components of the microscope are ubiquitous, from primitive forms to our advanced forms. Primitive forms of the microscope, they still possess ocular lenses. They still possess a stage-like area for the specimen to be placed upon. They primitive microscopes had light sources also, but they were structured very differently than our microscopes are. Basic information on the microscope is that uh, they are they are used in most life science courses. Um, Science majors as well as non-majors typically have to deal with microscopes at some point. Even if you're majoring in business, for example, when you're taking your core classes, it might be there might be a chance that you might have to take a biology course or an environmental science course as an elective. So, yeah, and microscopes are used from the elementary level all the way up into if you're looking to become a doctor, you might have to use a microscope. We're dealing with light microscopy, not electron microscopy, meaning that we can view most things under our microscopes, but we can't see neurons firing. We can't see viruses. There are certain microscopes out there that can magnify up to 125,000 the times the size of the actual specimen's size. Those microscopes are called Titan Krios microscopes, and they are huge electron microscopes that take up the entire room. There are scanning transmission electron microscopes, cryo-electron microscopes. Um, Truthfully, at that magnification, you can probably see neurons in your brain firing, or protons and electrons, which are way, way smaller than the nucleus and the mitochondrion that we are able to see with light microscope. As you can see, there are many different types of light microscopy. One type that we are definitely very familiar with is bright field microscopy, where you see an image against a white background. Both dark field and bright field microscopy employ halogen light bulbs or incandescent light bulbs, as well as LED light bulbs. In halogen light bulbs, you have a tungsten filament that is surrounded by halogen such as bromine, which is encased by quartz, which is in turn encased by glass. LEDs are light emitting diodes. They are commonly used in wide field fluorescence microscopy, and their bulbs last way, 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 way longer than halogen light bulbs do. In fluorescence microscopy, a mercury arc lamp is used as a source of UV light, which helps the specimen to be seen. In phase contrast microscopy, light is used to create destructive and constructive interference. In confocal microscopy, there's typically less bleaching, which can preserve a sample, and there's also less blurring of pictures, which can make it easier to document and to dissect what's going on with a particular specimen. It makes it easier to observe. It makes it easier to analyze. And polarized microscopy, polarized light coming from lasers creates a two-dimensional and or three-dimensional images. So in this slide, we actually can see a picture of microscopes as they existed um over 400, excuse me. No, not over 400. Over 300 years ago. Over 300 years ago. Um So to get into it, most people, when you think about microscopy and microbiology, you think of Antoine von Leeuwenhoek, and he was an atelier, a guy who dealt with clothing and materials and fabrics and threads and needles and all of those sorts of things. That was also very much so interested in science. Um, Clothing was probably his occupation. Science was more like his vocation or his hobby, but he tinkered around and discovered bacteria, protists, sperm cells from various different animals underneath his microscope. Before Leeuwenhoek, um, two other Dutch scientists named Zacharias Johnson and his father Hans Johnson developed the first compound microscopes, which, when we think of magnification these days, those microscopes were really just very strong camera lenses. Um, Not what we would I don't think, not definitely not what we would consider microscopes these days. Um, but basically, the technique itself has not evolved as much as microscopes have evolved. And what I mean by that is the technique has always essentially been the same. A sample is obtained, a sample is prepared, a sample is observed, and it is analyzed and recorded and documented in various ways. Back then, probably through drawing pictures primarily. Now we can take pictures and we can uh, do more advanced things with the specimen. But you obtain the specimen, you prepare the specimen, and then you observe the specimen. What is the definition and the purpose of the technique microscopy? Well, if you can recall, microscopy is the study and usage of microscopes. What are microscopes? Tools that are used to observe extremely small objects, objects too small to be seen with the naked eye, like cells, membrane bound intracellular molecules, microbes such as E. coli, salmonella, um, plasmodium. Uh, yeah, that's what the definition of microscopy is. That's what microscopes are. Purpose of the technique is to observe very small objects. Microscopes are used to view slides, and slides are prepared through obtaining a specimen or sample, smearing it against a glass slide, applying some sort of liquid or solution to the specimen on the glass slide, and then you cover it with a cover slip, and then you adjust it, you put it in a microscope, and you look at it. It's really very simple, and you know, if you're taking this course, which is what, like a 4 level course, this is a senior level course, you pretty much well know what a microscope is. Ah. So, what are the current applications of light microscopy? Current applications include scientific analysis. Uh, it can be used in healthcare. It can also be used in material analysis. For scientific analysis, it can be used in laboratories to develop vaccines, to look at cells as they are exposed to different environments. In healthcare, light microscopy can be used in benign versus malignant tumor differentiation, meaning it can be used to determine whether a tumor, whether a cancer is malignant, meaning it is actively growing and it is life threatening, or it's benign, meaning it is not life threatening, but, you know, potentially needs to be removed before it becomes malignant. Um, in material analysis, you can look at materials under various circumstances to see how it reacts to uh, various conditions. Will this material dissolve when it's wet? Will it expand or shrink when it's wet or when it's dry? You can look at powder particles such as talc baby powder and see the carcinogens within it and prevent people from potentially getting sick from it. You can discontinue things based off of what you find in the materials. And believe it or not, like this also has applications in even the fashion industry. What if someone makes clothes and they try to smuggle cocaine into the United States with their clothes? Well, with microscopes, you can see the drugs being smuggled in and prevent that from happening. What are some technological advancements of microscopes? Well, for one, they are lightweight and easily transported, which is a huge difference from 300 plus years ago, where microscopes were divided in two or more separate pieces that had to be carefully transported, carefully handled in order to prevent it from breaking. Don't get me wrong, we still have to be careful with microscopes, but they are much sturdier. The lenses and light sources work together to produce a stronger magnification, and many types of microscopes these days have a detachable battery source. As far as the cons and limitations of microscopy as it exists today, there really are very few, if any, drawbacks. It's not the strongest magnification. We certainly cannot analyze all living things, but they are perfect little tools for what we need them for in the lab. So, technological advancements have come a long way. So, in conclusion, microscopes have come a long way over the past 400 plus years of their development. They are very useful and ubiquitous, meaning they are all over the place. They are very widespread. Um, their usage is so multifaceted, multi-purpose. They're very necessary not only in science, but for many technical and objective research purposes across many different disciplines, not just what you may typically think of as related to or pertaining to science. Are there any questions? The floor is open. Ask me anything. These are my references for my pictures, and these are the references for my information. Thank you so much, and have a blessed and prosperous day.